Hi everyone, it's David from Automotive Press. I have Sheldon Brown, Chief Engineer for Tacoma. What an honor to meet with you and talk about Tacoma and maybe even the 4RUNNER. Thank you so much, first of all, for redesigning this iconic truck. I love Tacoma. I owned 4 different ones in the past. Maybe I'll own the new generation version as well.
Excellent.
But we are so excited about this model, and you're the key person for that. So we have the chassis of the Tacoma right behind us. I'm hoping Sheldon can point out some interesting things that you might not be aware in terms of the Tacoma, and I guess a lot of stuff that applies to Tacoma also applies to 4RUNNER as well, right? So
Absolutely.
maybe as you walk around, you might be able to point some of the differences. Okay. So tell me a little bit more about the iForce Max. Why is it so unique?
Sure.
It's got tremendous power and torque at very low RPM. People still talk about the fact that, hey, we went from V6 to Turbo 4. What about long-term reliability? You know, people still talk about that a lot in my channel. So first of all, maybe how do you address long-term durability with turbocharged engine, especially something as complex as the one with hybrid?
Yeah, great question, thanks. And by the way, the pleasure's all mine. I'm glad you could be here today so we can really get into the nitty-gritty. So we did talk a little bit about this. This is our iForce Max, and of course the iForce is still the the basic underpinnings of the engine and the 8-speed transmission are basically the same. The difference there is that one motor generator that we sandwich in between the 8-speed transmission and the L4 turbo. Now, the point to durability, right? This is something that's been a question that we're hearing a lot of, and rightfully so. This is new technology. People are maybe not as comfortable, maybe not as aware of it. Right. But the key point, and maybe the difference between what we think about as a traditional, or maybe historically when we've added turbos, those were engines that were meant to be naturally aspirated, and then later turbos were added to them. And so this was an engine that was built from the ground up with the understanding and the design parameters to support the hybrid, or sorry, the turbo boost, right?
Okay,
and that's a really important difference because those compression ratios and that forced injection, that direct injection, those type of things were already considered when we built the engine and the block, right? So we know there's a couple things we talked about in the briefing earlier today. One of the things is heat management, right? And so we know that there's a lot of heat that gets built up here, and we talked about those inlets being much bigger, right? 70 millimeters, almost 3 inches, something that we would have seen on a traditional like 8-cylinder or V8 block. We're putting that into an L4 because we know we got to keep those things cool. But in addition to that, we also know that truck users are using their trucks differently, for example, than maybe the rest of some of the applications for the similar L4 motor. And to that extent, we also look to use our commercial grade for our turbos. And what that really means is there's about a 50% increased duty cycle, and we do our testing, of course, to that higher standard. So they're thought and they're designed with the loads and the duty cycles in mind. And so as a result of that, we can assure the quality, the durability, and the performance that our customers have really come to expect.
I see. Okay, so those are really important points. But people, again, still compare to the 3.5 V6 in Tacoma, the 4-liter V6 in the 4RUNNER, and people say, hey, those things are bulletproof, they will last forever.
They will.
Can we make the same kind of claim with the turbocharged iForce Max engine? Could they not? I'm not saying forever, but could they last as long as naturally aspirated engines?
Yeah, there's no reason to believe they wouldn't, and in fact, we test them to those exact same standards, right?
Okay.
Especially think about the truck motors. We're the same things that we did in the naturally aspirated motors, tilting them up on the bench, making sure that we're not starving them for oil when you're going up hills and on sides. We're watching to see how that's happening, making sure that we're staying lubricated, making sure that we're staying cool. And again, we're running the same duty cycles, we're running the same requirements, and we're testing to those same standards. So it's, to be very clear, we aren't compromising on our QDR just because we're putting in these newer engines. And so I think what you can rest assured through is the same sort of scrutiny that we've gone through historically and we've developed these engines to in the past is the same I'll say rigors that we're putting into these new engines.
Right.
And I think another really important point is, well, maybe in the North American market is somewhat new to turbos. Toyota's been using turbos for quite a long time. So we do have a long history with that, whether that's in the diesel world or in some cases in the previous generation, smaller replacement turbos as well.
Right. So there's no reason to believe that it could last 1,000,000 miles if we take care of these engines.
Again, 1,000,000 miles is outside of our normal development standard, but as you know,
Right.
These trucks and these engines are built, in many cases overbuilt to make sure, we're always thinking about that, that very extreme use, and we're building to make sure that we cover for that. And so as a result, for the general user, the average user, they really are largely, very durable and many times overbuilt.
Overbuilt. Okay, excellent. So that's the powertrain. Anything else to point out? Oh, by the way, I was going to ask.
Sure.
On all the 2.4 engine, not just
Yes.
in Tacoma, but there's no cover.
There's no engine cover.
Yeah, and
I'll be honest with you.
right?
I'm a bit of a truck guy. Truck guys, if you want to be able to get to your engine, you don't want to have to pull off a bunch of plastic parts. In some applications, the truck cover does more than just beautification. In some cases, it's very effective means for NV remediation. In our particular case, the hood insulator was far better for the applications that we were looking for NV performance. So when I came to we have the cost trade-off, right? We're always trying to keep the cost on these trucks down as much as we possibly can.
I see.
And part of that strategy is you put parts that have value, and you look at the value contribution. And so in this case, we spent the money on the hood undercover rather than on the engine cover.
On the engine cover, I see. So what kind of cost decision?
Cost versus performance, making sure that we've optimized the value.
Right. Okay. Anything else in terms of the iForce Max you want to point out?
Well, yeah. While we're on here, of course, we painted the different colors here so that you can sort of see things. But of course, this is our turbo assembly we have over here. We've tucked up our catalytic converters here. And these are the catalysts right up in this area. They're nice and tight up here. They're hopefully out of harm's way. Obviously, we use that for a number of reasons, but in the preheat to make sure that we get that to get them up to temperature really quick for emissions performance. Down here, we're actually using our hydro switching engine mounts, and this is really important in these smaller engines when in some cases they tend to vibrate a little bit more. We want to have that insulation. So we're using technology to offset some of the side effects of the smaller displacement motors. Here's our DC-DC converter, right? This is of course important. This is what steps up or down our voltage coming from our battery. I beg your pardon. This is meant for the purpose of display so that it's a vehicle correct position, but obviously this is not how it's mounted. We obviously have the body that's missing here in this particular model.
And what about the wastegate? I know in Tundra it's nothing to do with the Tacoma. They had some issues in the beginning with the wastegate sticking, and then because it was together with the turbocharger unit, they had to replace the whole turbocharger.
Yeah, so there was a little bit of an issue from I believe it was actually ultimately a little dimensional quality issue, and that allowed for some binding. Now that's an electronically actuated wastegate. You can see here on our wastegate, we're actually a vacuum actuated wastegate.
I see.
We actually have a lot more pressure and strength. More importantly, the line, if you will, the force that's applied, rather than being sort of the 4-bar link, is more of a direct application. What this allows is even if you get a little bit of sticking, for example, from some corrosion or something like that, we have the force to overcome that. Also, what's not shown here is there is actually a cover normally under this condition, and really that helps with a lot of the salt spray and stuff that gets up here and can potentially cause some troubles with those. But again, I think with the vacuum that we're using here, with the total different configuration, we're a little bit less sensitive, I would tell you, to that particular issue. But the great news is Tundra's got that all worked out, and it was a relatively insignificant number, but for those who were impacted, of course, it's it's an inconvenience that we don't want our customers to have to go through. So we were certainly mindful of that. And to be honest with you, that's what Toyota does. We say yokoten in Japanese, which is to pass along the information, right? And so we're constantly in collaboration with our truck brothers to make sure that we're learning
from each
from
other.
those launches, right? Tundra was the first one through. We learned a lot. We were able to apply that in Tacoma, and we're applying those learnings from Tacoma back into Tundra.
Yeah, I think the Tundra story got a little bit overblown. I think it was a very small number. Like I said, I own the 2022 Toyota Tundra as well, TRD Pro. It wasn't a problem of mine. But I think it was just it got a little bit gone off rail in terms of the media and so forth. But it was taken care of, like you said.
Well, that's one thing that we are committed to. We certainly try to make every truck perfect. That's our goal. We are humbly reminded some days that we fall short of our goal. And when we do that, then the measure of our customer satisfaction then is how quickly we react and we respond. So you have I can tell you, our firm commitment to making sure that we do everything that's humanly possible to make sure that we don't disappoint our customers.
Right. As always, right? Now, in terms of turbocharger, do you have to? People also ask me this question: do you have to? Is it ideal to let it, just idle for a little bit when you come from a hard drive or a highway drive and let it cool down, or today's modern turbos, you don't have to do any of that.
Usually today's modern turbos, we actually have oil that's moving through, we have coolant that's moving through, keeping them cool. So that is not really as important as maybe it was in the past, where we didn't have that sort of, I'll say intentional heat remediation.
Right.
So,
but would you still suggest, recommend when you come back, you just let it cool down for a minute or so? It's totally not necessary.
Yeah, honestly speaking, we don't really in our owner's manual, in our warranty and maintenance, we don't request that needs to happen. And like I said, for the most part, most people, you're not like coming right off the track and then shutting it down, right? So usually in that natural just sort of cool down cycle, as you move off road, you're going to find that you get that naturally takes place.
Right, like you're trying to park the car or something, it's already slowing down.
It's already cooling down. That's right.
Okay.
Yep. Absolutely.
Now, this is sort of a separate question, but there's a recommended interval for the oil change, and because I'm a mechanical engineer by background, I often tell people maybe change it like twice as often as recommended, even though it's not necessary. Is that a good, like, I know officially speaking, maybe you can't really say one way or the other, but generally speaking, more frequent oil change would be better, right? If it's okay in terms of cost.
That's a tough question, because there's the mentality of more is better, but obviously what we prescribe in our owner's manual and with our service is really made sure that you can optimize the amount of time that you spend and the money you spend on service versus what your value that you're getting out of that is. So we're always trying to do that. One of the things that's really important to know, though, is with these synthetic oils and these new lubricants, their performance is significantly better than what when you and I grew up, right? And thinking about the engine, the oil consumption, and how often you had to change it. It's really changing, and I think sometimes we don't talk about just the chemistry of these new oils and how much they progressed. Say not even I would say in the last 30 years, but even in the last 10 years. And so that's what's allowing us to go a little bit further, because we're just not seeing the amount of breakdown of those fluids now. So I would say, always the best bet, right, is to make sure that you're, monitoring your oil. That's always a good practice, right? We let you know when it's low, but it's always a good practice to keep a look at it, looking for the color, making sure that there's no impurities or something is, maybe gone amok. But as a general rule, follow what your maintenance guides are, and you're going to be in really good shape.
Okay, super. So moving away from the engine for a moment, it's also really hot over here as well. So moving away from the sun, tell me a little bit more about the frame, because I know the frame design has changed dramatically.
Sure.
It's you guys are using blank welded design and so forth. What's the difference between before and after?
Yeah. So we think back, like if I go all to the previous Gen 3 Tacoma, right?
Tacoma, yes,
so we had that, we call it that tri-construction frame. We were boxed in the front. We had sort of the partial C, or the partial section here, and then the open C channel in the back, right? And in that era and that technology, that was really good. It allowed us some frame twists versus some flex. But the downside of that, of course, was some of the side effect to the on-road stability and the body roll, for example, during on-road driving. So with the new TNGF platform, we set out to build basically a truck platform or a truck frame that would be able to be used across multiple different vehicles. And we did that fundamentally by really trying to keep the general silhouette of the front, especially the front and rear kick, the same, using this center portion here to adjust for wheelbase length. And then you really touched on one of the really key enablers of that, and that is that Dejima welding, or what we call, that's Japanese for island of strength, we call it. And then, but what we'll say is Taylor laser welding, right? And so we're taking these Taylor welded blanks, and we can actually see that right back here. This is a cut section. Hopefully your camera can pick this up. So this is an area, for example, where you can see where we have that Taylor welding here. And what we're doing, we've cut this away to show you. So as the C channel is opened up, we can then cut out that shape, put in for example, a thicker piece, or in some cases maybe a higher gauge or a higher tensile strength steel in there, because this might be a stress concentration area. So as a result, you can see the difference in thickness between the pink and then the white. And so then once we weld those together, we can then form it, and then we bring these two and weld them together.
I see.
So that allows us.
One section is being strengthened.
That's exactly right, and that's where we're taking a lot of that stress. You can imagine, right? We're getting a lot of force input coming right in here. So we need this section to be incredibly strong. Historically, to do that, we would have had to either gauge this whole panel up, or we would have had to add like gussets on the inside. And obviously, one of the downsides to like a gusset type application, in addition to additional welding, etc., we have heat affected zones, which make it more difficult for us to get really good adhesion of our anti-corrosion. For example, our phosphate coating or the E-coating on here. So what's really good about this is all that flows right through here. We get good consistent coating both on the inside and the outside of the frame. So it also improves our corrosion performance or anti-corrosion performance.
But that's another question sometimes the viewer asks is about the frame corrosion. You know, has it improved over the years? And you know, in the past there was some issues with that. But what you're saying is that the E-coating or the phosphate coating goes all the way through, so it's complete coated.
That's right.
And then you guys still paint on top of that, obviously, right?
That's what we're using, especially back here in the areas where historically we might have seen some corrosion on the trailer hitch, because one of the things is these can be sensitive to UV, right? And that can take, over time, lots of exposure. So when there's areas that are exposed to sunlight all the time, I'm not talking about indirect sunlight, I'm talking about direct sunlight, you know, beating on that at all times. And what this allows, so over here we actually use a powder coat on that trailer hitch. Sometimes you used to see corrosion around the welds, etc. Well, now we're actually powder coating that so that you don't get that.
Oh, interesting.
But this is being completely E-coated, and then in the areas where we've even had additional, I'll say quote unquote, some problems where, you know, sometimes we can get mud or dirt or something up in there that can hold moisture. We've actually, along those areas, which is typically in the center section, we've added wax as well.
Oh, I see, special wax.
That's right. And then what this wax is, it's atomized as we spray it in there, and it really just gives like another protective layer. And what it does is it just extends our corrosion performance even further.
Right. All right. So last question is just the design of the frame, which is a platform. I guess you can call it platform, a TNGAF platform.
Yep.
You've got so many different models using TNGAF platform. I know that the basic design of the frame is shared among many models.
That's correct.
In some cases, identical, right?
Very, very similar. That's right, exactly. So
and that's again to reduce the cost, reduce the product development time, so forth. Tell me a little bit more about what are the differences, let's say between Tacoma and the 4RUNNER, or between the Tacoma and Land Cruiser 250 series.
Sure. Okay. And mainly I'll speak, what I can speak to is, for example, Tundra, Sequoia, 4RUNNER, and Tacoma.
Sure.
Right? And obviously the most obvious thing is wheelbase. Right?
Yes.
I mean, that's pretty straightforward. You know, our base wheelbase is 3350. I think that's 3,350. That's 113-ish. Yeah, right, 113 inches.
I think,
Yep. And then, you know, we're at 2850 on the SUVs. I think that's the same for both Land Cruiser and 4RUNNER. And what we're doing, again, keeping most of this the same, we're actually taking that out here in that center section. Now, you will see a slight difference because we also have a shorter wheelbase. You'll notice the fuel tank is going to be slightly different on the SUVs versus the trucks. The trucks are a little bit longer and skinnier, so we can maximize volume. On the SUVs, we have to make them a little bit rounder, a little bit wider. So there's some other packaging differences that we have to do. And then of course, you know, we take a look at the number of cross members based on how we're, you know, the difference between really the truck and the SUV. And for example, the Tundra, we're bolting on this rear cross member, whereas in the SUVs, we're welding those on. So those are just subtle differences based on the overall frame architecture. But for the large part, they're very much the same. Now, where they do change, again, based on the vehicle mass, is in the thicknesses, and in some cases in the materials that we're using based on how the input loads are coming into the frame. So there's much that's in common, and you think of it rather than like large redesigns as sort of tweaks or optimizations based on the unique characteristic of that particular vehicle performance. And those are largely based on, you know, the differences in the input loads, the wheelbases, and those are really the big factors. Right? Sometimes we also have a 3700 or 3685. The Tundra C cab is 3700 millimeters. So they're very, very similar in terms of, you know, they overlap a little bit with each other.
I see. The other thing that we notice, and sometimes it's a little bit puzzling for us, is that in traditional sense, it used to be the gas tank, or where you fill up the gas tank, I should say, was usually on the old car was on the driver's side, but the exhaust was on the passenger side. Mainly, I think I heard because in the snowy conditions, you don't want the snow plow to come through and plug up the exhaust. So that's what I heard. So it's usually opposite from where you fill up the gas tank. But now they're both on the same size. Okay. Right, driver's side, and then the actual exhaust is also on the driver's side. Was there some reason behind that, or is that also part of the standardization thing?
Well, so this is part of the global standard, right? So we had to decide. We have sort of a fundamental policy at Toyota that the fuel filler should be on the same side as the driver.
Okay.
And as you know, on a right-hand drive vehicle, that means the fuel filler's on the right-hand side. A left-hand drive, it's on the left-hand side.
Yes.
So at the end of the day, we had to decide, okay, what side are we going to put the fuel tank on? Because we wanted that to be common.
Standard.
And so in our particular case, we said that we still need to follow that principle. So ultimately, as a global decision, we decided to put the fuel tank on the right-hand side, which you know, from a vehicle dynamic standpoint of view, isn't the worst idea for a left-hand vehicle because you've got a little bit of counterbalance from like, you know, traditionally just a customer. But that wasn't the real reason. We looked at where we wanted it to be from a manufacturing feasibility and consistency across all of our plants. But then we route the fuel filler all the way over to the other side so that we don't inconvenience the customer.
I see.
And then fundamentally, you know, we're trying to get that exhaust out as quickly as we can. So we didn't want to cross over the vehicle if we didn't need to. Right. But if the fuel tank's here, that means the exhaust is over there, right? And now think about this. We had to think about the best location and position for a number of different global powertrains. So you might say, well, that doesn't make sense on the L4 because in the L4 case, we're coming off the right side of the engine. However, when we think about the V6 twin, or if we think about the GD application for other global markets, we had to balance between all those. So in the early planning, we made some decisions, and you know, as rock, paper, scissors, and we got to the final conclusion. I kid about that. There was actually a lot of technical. A lot of technical thought that went into it.
But you had to balance basically standardization globally, cost,
That's right.
And then figure out what's the best outcome basically.
That's right. And that is a multivariable equation.
Yeah, no, because it's so global now, right?
It really is.
Not localized. So my last question was around to kind of understanding the nature of the product development. So you have, I know that Sequoia and Tundra were jointly developed, North American developed in terms of engineering, even the manufacturing because it's Texas based. And then, but then you get more confusing when you get to Land Cruiser level because Land Cruiser 250, I understand chief engineer is Morita-san from Japan, right?
Absolutely, yeah.
But he's also, I understand, was in charge of the 4RUNNER.
Yeah.
In philosophy, is that right?
Yeah, that's very true. So the way that works out, we're really truly a global team, especially the chief engineering office. We are in constant collaboration with Maritsu-san and his team. He and I and the rest of our teams, we did the concept planning for both Tacoma and the 4RUNNER at the same time.
Same time, yeah.
It made a lot more sense when manufacturing locations were decided that we were going to manufacture Tacoma in North America, obviously with a local supply base. We did a lot of that development, especially the fact that the Tacoma is obviously very much North American market faced. 4RUNNER is too. They might have a little bit larger export than, for example, Tacoma. So actually, Maritsu-san's team also engaged a lot of our engineering team for the areas that we share some commonality. So our teams had just finished, you know, the formal or the fundamental development of basically the front end of Tacoma. So it made a lot of sense for us to start to do that and support his team that way. A lot of his team worked on the B-pillar rear wood, but ultimately he was, you know, the final voice and the decision maker. And that's one really good thing about, you know, Toyota. We still are very much a global organization. That information exchange, you know, a lot of the platform planning, because it was global, we did that back in Japan. We brought it back and then did a lot of the continuation, the tuning for the powertrains, the tuning for the suspensions, all of the sort of the chassis part development, including the upper body development, was done here in North America so that we have that North American quote unquote flavor. And I think that's one of the big strengths that Toyota recognizes is regional development centers that can really understand the characteristics that particular market is looking for while still maintaining, you know, the core identity of what Toyota stands for, right? So we recognize and we think it's you know, incredible, you know, honor for us to be able to say, to have, you know, the parent company put that level of trust in us to be able to execute on a project, you know, as important as Tacoma. So, you know, Maritsu and I had lots of great collaboration as well as both of our teams. And so you might have had a chance. Ohara-san is here with us today, and he's one of the representatives from the 4RUNNER team. Yeah, we meet weekly. Yeah, really great guy. We're happy to have him, you know, to celebrate the launch and the reveal of the 4RUNNER. Yeah.
Do you think the 4RUNNER? I know it shares a lot with the Tacoma, but also by default, it also shares a lot with Land Cruiser 250.
Yeah, right.
Is it closer to 250, closer to Tacoma?
Well, it's interesting because I would say the SUV bits, you know, the parts, the rear portion, especially not only the suspension, but how we do all the packaging for the hybrid powertrain and the battery. You know, we're underneath the seat, they're underneath, you know, back in that luggage compartment area, the back door and all of that. That is very much, you know, there's a lot of commonality and a lot of, you know, continuous thought about how to execute those two products because they share a lot of perhaps hardware, etc. Whereas, you know,
you mean the Land Cruiser and the 4RUNNER?
I'm sorry, between the Land Cruiser, the SUV to SUV, right?
Right.
But then what's kind of neat is up in the front in the instrument panel, etc. I think, especially if you look at maybe H point or couple distance, you know, W to W Tacoma, and in the 4Runner are very similar. So that sort of instrument panel layout and sort of the shifter layout and all of that area probably has a little bit more in common with Tacoma. Right. So 4Runner is really a really cool development truck, and the fact that we have these brothers that are all sort of built on the same fundamental platform really is what we can pass on then to the customer is, you know, the optimization of the amount of investment that we needed, and of course the development lead time and the development cost.
Right. So the 4Runner could be almost like kind of half a Tacoma in the front and kind of half a Land Cruiser in the back. Simplifying it a little bit too much,
but a little bit oversimplified. But as a general rule, yeah. I mean, SUVs tend to be more similar in their structure, right? And then where in the front is where we can see some of the commonality to Tacoma. Front overhangs are the same. You know, front stabilizer disconnect bar. Yeah. These sort of underpinnings are very much similar.
Now, the 4Runner was, you know, I guess many viewers are happy that it's built in Japan again at Tahara. So was that mostly capacity thing? Like, because if it's similar to Tacoma, you know, many people thought that it will go to Mexico in terms of manufacturing.
Well, you know, it's important that we look at our global production footprint and where we're going to go to different markets, and then also, you know, we're balancing global capacity. But the great part about the Toyota production system, right, is it is a process, and it is a philosophy that can be embraced and can be taught and shared everywhere we put Toyota plants. And so we still practice those same fundamental principles. In the case of Tahara, which is certainly a plant of manufacturing excellence for us. We have they're sort of our sister plant here with our Mexico production, and we had members from Tahara here supporting the development in the production integration of the plant. We had folks from our global production engineering team together with our North American production engineering teams doing all the work. And so that's the great part about Toyota, and that's how we keep our quality no matter where we manufacture.
Right. It doesn't matter that there's no more boundaries anymore, is there?
It's a global business. Yeah. And it's about taking that culture and being able to repeat and copy that culture. You know, we always say it's based on respect for people, and that's the foundation of that culture. And then we apply those same principles and that same respect for people to motivate our team members to excel and to follow that Toyota principle. It's tried, it's true, and you know, so far it's undefeated.
It's what makes Toyota Toyota, right?
It surely is.
TPS, Toyota Way, Toyota philosophy. I'm curious as a last question, your Toyota Connected division uses Agile and Scrum because that's what they tend to use in the software world. But Toyota has a Toyota Way, TPS, and so forth. Did that merge at some point so that your concept of Obeya, for example, the big room concept, and the concept of Scrum, did that merge at some point?
Well, you know, the great part is, again, we start to blend that. So I would almost call it a little bit of a hybrid culture in areas that we had to rethink about how we were doing, for example, the electrical system integration. We've applied some of those, Toyota connected principles and more modern, I'll say, electronics practices.
Okay.
But then there's still some areas that are I would tell you that are very much our traditional methodology, especially as we think about how we're planning some of the other elements, for example, the foundational elements of the chassis or certain areas there where we want to do some of that base engineering up front, get that right, make sure it's solid, and then move from there, as opposed to doing a lot at the same time.
So those are still, so there's some traditional thinking mixed in with some modern thinking at the same time.
Yeah, we have to be flexible, right? And we have to make sure that we're embracing, what got us here, but also making sure that we're not, putting our head in the sand and not looking at to what the future is. We're always striving to, the faster we can get to market, the quicker we can satisfy our customer, but we can't compromise on quality.
Right.
So there's a little bit of a misnomer that if you do it fast, there isn't quality, and there's the other side, if you take a long time, there is quality. They're really not connected. It really has to be jointly considered, and you need to really think about how do you achieve both.
Right. Excellent. Well, thank you so much, Sheldon. I'm sorry to take so much of your time. Our viewers are going to love what you had to say because they just love the Tacoma, they love the 4Runner, but also all the stuff that goes behind the scene that people don't talk about. They're very curious about that, and I love talking to you. And so my highest respect for you for all the work you've done. And thank you so much again for being with us and for designing such an amazing truck.
Thank you. It's been an absolute pleasure. Really enjoyed it.
Thank you so much.